the recorder so that we get the recording done. Good morning, everybody, or afternoon. I'm not sure whereabouts in the world people are all sitting. My name is Tommy Atkins, and the elephant is actually an African name for that elephant is TEMBO, which is where the name of our company comes from, so I like to stick it up at the beginning. Right, we'll go through some of the basic formalities first and look at what the next 20-odd sessions are going to be dealing with as an overview. AO Advanced Modernization Workshop. This course started out actually as a workshop with people working in front of me with terminals. You will, if you have the tools, be able to do the same thing as we go through. I would recommend that you use it as a workshop, even if you don't have the AO tool, which is the AdZero Optima product. You can still work through the workshop and get a feel for how all of this comes together. Advanced modernization is a process which we are going to discuss at great length over the next 20 sessions. It encompasses an enormous amount, and our examination of advanced modernization techniques and methodologies will relate only to the IBM I and its operating system, and we will not be taking, and of course its primary language, which is RPG, and we won't really be doing an in-depth look in much else except the SQL components that give us a modern development or building blocks for our database. So it's an advanced modernization workshop. In the beginning, I want to talk a lot about this whole business of modernization, the why, the wherefore, the how, the when, and everything like that. But before I do that, my name is Tommy Atkins, and I would just like to introduce myself and basically show you where I've been for the last number of years. That's me in the top right-hand corner, and a very fast and rapid trip through my CV. It started in 1969 as a trainee operator on a Leo 3 machine. These pictures are my favorite pictures. This was a computer that I started my IT career on. The middle picture shows the main control panel. The left-hand picture is the operator's console, and the right-hand picture is a printer and a set of tape drives in the background. This machine had a vast capacity of 64K. It was actually smaller than the first calculator I ever bought, and it was able to do one job at a time. Pity it no longer. You can see it in the Smithsonian. There's one in the Smithsonian if you go and visit there. From there, 1972, I became a COBOL programmer working on ICL 450. This was where I first encountered replaceable disk drives, which are those units over there at the back. And then in 1974, I became an RPG programmer working in RPG, no numbers, no letters, nothing after it, just pure RPG, on a system, IBM System 310. That is a picture of it. Approximately. It was a card-based machine, didn't have any disk drives or anything like that, was completely card-based. Then in 1975, I started programming in RPG2 on an IBM System 32. In fact, this IBM System 32, at that time, I was working at a company called Console Glass, who manufactured glass bottles. And this was the second IBM System 32 in the country, and I actually removed it from its crate. So that was great fun. So that's where I started my RPG in 1975. Well, sorry, in 74. and it actually got a couple of numbers behind it in 1975. Then, from then until now, and I gave up trying to put dates to any of this because it's been going on for so long. System 34, 36, System 38. The terminal, to me, is a historical unit, and if anybody has one, I would gratefully accept it as a gift because they were the most indestructible devices around. And then, of course, the AS400, and then from there onwards, iSeries and IBM I, which is where we are at the moment. And just so that one understands, I'm a complete and utter bigot when it comes to two things: the IBM I and its predecessors. And I understand what people say when they say it's an AS400. To me, that was the iconic machine. And the second thing is the language, RPG, which is actually the primary design language for the IBM I and its predecessors, and is certainly, in my opinion, the most powerful transaction processing language available today. Although I know there are probably hundreds of people out there who disagree with me. If anybody disagrees with me here, then I would very much like you to send me a rude message if you feel like it in the chat box, just to let me know who you are. My whole focus of my entire career has been database and application design and development on the IBM iSeries, IBM I and its predecessors, the design and the development of databases and applications. So I'm hands-on, I'm very practical. Theory, I find a little boring if I can't put it into practice. As a result, everything that I have to say is actually tried and tested. I don't espouse theory without having had it tested and actually implemented in a real application environment. And this, I believe, is a great asset because I know how hard it is to actually complete a system, an application, a database, and get it to work 100%. So that is where this whole workshop is coming from. Practical implementation of database and application design and development, but shifted into the modern era. Right now, I'm just going to, this is my interrupt screen, which should pop up. No, it doesn't. Some of them pop up with a question mark, which allows you to ask questions. Let's talk about some rules and other things, just quickly. I will be stopping at regular intervals in between sections, give you opportunities to ask questions. You just unmute yourself, ask a question, or you can send me questions in the chat box. But I would like it if you would send any questions, send them to everybody, so that everybody can at least see the question, so I don't have to repeat the question when I'm providing an answer. So that's the one rule. The other one, of course, is the very common one. Please turn off all your cell phones, although it doesn't really apply in this circumstance. Those are really the only rules. It is important. I want it to be as interactive as possible. Obviously, we have to keep some control on it because otherwise we're going to run behind the clock. So that's, if I think of anything else, I'll come back to this one. It's not quite as, I put that in just to remind me to discuss it. Right, oh, there's one other thing you'll find. I have a couple of favorite things, people, and I tend to post quotes or funnies around those people quite frequently. And this one is a list of attendees. Now, I've already noticed that we have a deviation from this list of attendees. Some people are not present. Others, like Vatcha Caprielian. Vatcha, I notice you're not on this list. I don't know which company you're actually associated with, but welcome anyway. If you can just send me on a chat box who you're associated with, I would appreciate it. Some of the people will be joining us on a regular basis. There are some repeat offenders here who make me feel very great because they actually have come back for more, which means I did something right the first time around, because you know this is the second time we've run this course. And we have some potential customers on the list, and we have some agents and dealers. And there on the left-hand side is one of my favorite people, is one of the minions. And certainly for me, I don't know whether I have any people on this list whose baby photos were taken on cell phones. If you are, then you're going to have to put your hands up as well, because that means you're a lot younger than I am. But the minions are my favorite people for all sorts of interesting sayings. Okay, is there anybody here who, no messages? Okay, good. Let's move on then. Right, this book, written by Alvin Toffler. Alvin Toffler is one of my all-time favorite people. He wrote this book in 1970. That was actually before I started in the computer business. Well, about the same time I started in the computer business. And I don't know how many of you have read it, but thank you, Vatcha. Future Shock was an amazing book. He's a futurist, and he predicted what is happening now in 1970. And one of the most important quotes around this book is a definition of what future shock is. And I will tell you now that this whole modernization concept, process, and drive has put us all into a state of future shock. Future shock is the shattering stress and disorientation that we induce in individuals by subjecting them to too much change in too short a space of time. And what has happened in the IT industry is that so many things have changed so fast that we are all thrashing around in a state of future shock. And it's depicted by feelings of not knowing quite how to approach a problem, how to do what people are asking us to do. And of course, if you think the IT people are in a state of future shock, of course, in this state, it's current shock, then you must try and imagine what the users of the computer systems are feeling with all this technology that's been thrown at them over a very short space of time. And 30 years is not a long time to absorb this type of technical advancement. So this is the beginning of what we're trying to do with this course and this view. We're trying to eliminate or damp down this feeling of shattering stress and disorientation, and work out a method and a process by which we can move forward, gain the benefits of the modern technology and the modern methodology without A, suffering a nervous breakdown, or B, destroying the systems that we've worked so hard on for the last 30 years. So this is a quote which explains what has happened and why everybody, and I'm saying everybody, in all areas of the industry are struggling with the massive evolution of technology that has occurred over the last 10 years. All right, the other quote that I want you to consider, don't worry, is another one from Alvin Toffler. And this one is also sorry, when I pause like that, somebody's written me a little note. This one is also a very, very, very significant thought. That the illiterate of the 21st century, that's where we're sitting at the moment, will not be those who cannot read and write, but those who cannot learn, unlearn, and relearn. And this is the essence, the crux of the modernization roadmap. We are going to have to unlearn and relearn things that we've been doing for years. And this is a hard one. This is a hard one. Unlearning and relearning, and I suspect there are quite a few of you who maybe not as old as I am, but are getting there. It's hard to unlearn habits of years, of decades even possibly, and relearn a new way of doing things. But that is the crux of modernizing you and the applications. They both have to happen together. My other favorite person is Albert Einstein, who had an incredibly and amazing sense of humor, apart from being a brilliant individual. And this was one of his quotes that I very much enjoy. And he's right. Computers are tools, and they're getting better and faster and more accurate and more flexible and more stupid as time goes by. It's up to us to make them work to our benefit. So that's another thought. I'm going to come back to these. I'll pop these up every so often just to remind you of where we're going with this modernization, because it's not an easy process. Right, here's a question that I get asked about, oh, I don't know. Every time I speak to somebody about modernization, application modernization, what is the best way to approach application modernization? Is at the moment the definition of modernization is not clear to a lot of people. What do you mean by modernization? And part of what we will be doing today and on Thursday and even after that will be to understand clearly what modernization actually entails. Because it's not a simple concept. And is not a silver bullet to achieve it either. And this is the question that we need to answer quite clearly before we get into any technical details about how we're actually going to achieve the modernization. We have to know what that modernization actually is. And there's one place where modernization has to begin. And only one place. And that's in your head. You have to start thinking modernization. Whatever that means, you've got to think it first before you can do it. And so probably the most difficult thing in modernization is not the technical aspect of doing the job of modernizing your application database and its environments, but to get your mind to start thinking in a modern paradigm. And honestly, I'm going to show you over the next 20-odd sessions or whatever it is, I'm not even sure. Yeah, about 20-odd sessions or 40-odd sessions, I think. I'm going to show you a lot of things that contribute to modern applications, to modern databases, to modern techniques. But none of them are going to last or stick if it's not your mind and your approach to the whole modernization philosophy that gets modernized first. And this, of course, takes me straight back to Albert Einstein. You see, I could have thought these up myself, but I didn't. I used other people. We cannot solve our problems with the same thinking we used when we created them. I've picked up another one which I haven't put in here, is that old keys don't open new doors. It's the same philosophy. If you continue to think the same way you have been thinking up to now about the development of applications and systems and databases, you are simply going to recreate what you have now. We need to have new thought patterns, new mental approaches in order to create and solve the problems and modernize our systems. Now, one of the important things, critical things that occur during the process of modernization is, whereas in the past we had these large monolithic programs, 220,000 lines of code, and believe me, that's not a joke. I worked on a program that big. We have these large monolithic programs. In the early days of RPG, in display files, when we had to use the cycle, if any of you remember this, these were huge programs. The early days of RPG on the System 34 and the System 36, we couldn't call other programs using RPG. So we had to write a complete solution in one set of code. Modernization goes in the other direction. It minimizes the different components of code into single function or single thought processes, which can then be wrapped up in procedures, modules, service programs, other programs, etc., etc. It can be wrapped up. What will happen when we modernize, and the more we modernize, and you will see it as we go through the course, we start getting more and more smaller and smaller and smaller programs, procedures, modules. So what's happening is we are multiplying the number of objects and massively reducing their size. So we are in the game of producing systems with smaller pieces. And the thing that comes to mind most as a good way of illustrating this is Legos. Now, I'm sure that all of you know what Legos are. But that's what we are going to do when we modernize applications. We're going to create building blocks with different attributes, and we are then going to plug them together to provide the business logic that we need. And this takes me back to another quote. Don't worry, this stops after a while once I get you so saturated. Alvin Toffler again. You've got to think about the big things while you are doing the small things, so that all the small things go in the right direction. And that is modernization. You've got to get your mind around the big picture And then you have to start creating the components. But only if you have a mind around the big picture can all your little components form a nice set of Legos that are all heading in the right direction. I'm already sensing, even though I can't see any of your faces, but usually at about this point in time, everybody is saying, my goodness, I don't really know what you're talking about or where you're going with this thing. Please understand that the first couple of sessions are going to be a shock. They most definitely are. It's the beginning of the unlearn phase, where we've got to start thinking in a very different way. And although it seems a little bit random, it's not actually entirely undeliberate. You've got to get your mind out of the rut and start thinking new things. Okay, I've just had a comment from one of my previous students on this course who said it's hard to unlearn but still support the current as well as thinking big and small at the same time. Now that sort of sums it up. You've got to carry on thinking like you used to think all the time, because all the stuff that's there has still got to be maintained. Then you've got to think about the big solution and the small things all at the same time. And it's not easy. And nobody, and this is something that I have to stress over and over and over again. It's not easy to modernize. And if you want to modernize properly, you get your mind into the whole process. And of course, the reason people are so scared of modernizing, and I mean that, people shy away from it, because it's actually you get overcome by a sense of future shock. You don't know where to begin, how to proceed, and at the same time you need and are absolutely required to minimize the risk to your organization so that you don't destroy what you have in place. And this course, this set of 24 sessions, I have been reliably informed, is intended to give you the tools and a pattern of thinking that will aid you in moving into the modernization paradigm. I am not going to be giving you the silver bullet. I'm not going to be giving you all the answers to all the problems, because that would take a lot more than 24 sessions. And each company's applications and logic requirements and needs are different. So there is no one answer to any one of the problems. So the focus of this set of sessions is going to be to give you an idea of what modernization, what is required to start a modernization process. And you, and this is honestly, you are the people that are going to have to drive it. You can't call in a contractor and say, come modernize my system for me, because it'll take that contractor 10 years to become familiar enough with your system, or as familiar as you are, in order to be able to make the right decisions about modernization. So it has to be done the other way around. You have to be the people who do the modernization, and you need to get assistance in what steps and how you approach the modernization. Because the knowledge of your system is sitting in your heads, and that is the power, or the thing that is needed most to modernize, is a knowledge of the existing system. Right. Let's get down to here. This is a little thing to try and illustrate what I mean when I say modernization is difficult. Legacy or heritage systems, just put yourselves in the position of the little gold man there. And I'm sure that sometimes you feel exactly like a hamster in a wheel, running to keep the wheel turning, and you can't stop. There's some things about that picture I need to point out. First of all, you're running uphill all the time. It's not downhill. It's all uphill. And secondly, you're running with bars in front of your face, so the view is lousy. Let's look at where we want to go. We want to actually, once we've modernized our system, at the end, we want to be where that gold man is, the second one. We want to be on top of the wheel. Nice view. You're running downhill. But I'm pretty sure you can understand what I'm trying to say here. Getting up on top of the wheel, practicing to stay there, is much harder than being inside the wheel. You need to make a big change. It's a learning curve. It requires commitment, skill, and a drive. Once you get it, your life becomes a lot easier. Because once you have a modernized system, you can do things faster. You can adjust your system quicker. And you will be hearing me talk about all sorts of benefits of modernization. Agility, ease of testing, etc., etc., etc. And as we go through all the different components, you will see where I'm going with this. But this is to say, you've got to get out of the wheel and you've got to get up on top. That requires learning, and it requires practice and perseverance. Who am I? Nalini Gold. Welcome. So that is another picture of why I'm saying modernization is not something you can do over the weekend. It's a long-term commitment to making things better. When they are, and you know, the thing here is you may never modernize part of your system. It may not be worth it. You may choose to modernize only those critical components or those most utilized components. You don't have to do a whole modernization. You need to modernize everything to make your life easier, and some stuff may not be worth it. But there's a lot that is worth it, and you need to commit to. All right, moving on. Let's have another view of the legacy system. This is what a typical legacy or heritage system looks like at the moment. And it's not an accident that's got a carved stone background either. I couldn't find a cave wall, otherwise I would have done it in cave paintings. Very much integrated into one piece. Programmers on legacy heritage systems were always responsible for developing the physical database and for developing the logical database as required, writing the application code, and of course through display files, attaching an interface to the application code to communicate with the user. So it was very much a small picture, and it was managed by pretty much entirely by the programmers themselves. I'm going to make a statement here. I'll make it probably another 10 times or 20 times as we go through. But those of you who are thinking of getting involved in modernization need to appoint a database engineer. Because one of the most significant things about modernizing your existing application is you're going to take the database and separate it from your application logic. And you need somebody who is responsible for that database, because it will no longer be in the hands of your application developers. Let's have a look at where I'm going with that statement. This is the buzz phrase that goes along with modernization these days, MVC, Model View Controller, except it's upside down. And it should actually be VCM. Because up at the top is the view. That is the interaction or the interface between the controller, which is your business logic, and the user that is utilizing the system for the benefit of the business. The controller is a section where the business logic resides. And your current legacy systems, and this is an important thing, your current legacy systems have that business logic built into them already. It's been evolved over years and years and years of expensive development by highly skilled people. And the last thing you want to do at a point in time is to take all of that and throw it away and do something else. What you need to do is you need to take that which you have and grow it into a modern, easily manageable set of logic. That's the controller. The model is your business model. This is your data. Sorry, I've done it again. Clicked the wrong button. The model is your database. It is that section of your enterprise that contains the information that makes the whole thing work. Change those around and just replace them with something else. Interface, processing logic, and database. Three things. What we do is we want to separate them. And this is where you begin to hear ripping sounds as you start tearing these pieces apart. Now, the interface, we know. That's been a component of modernization, and at one stage it was the only thing you needed to do to modernize, was to make your application look pretty. The interface is definitely a function and a part of modernization. Your processing logic is separated from the interface, and your database is then separated from your processing logic, i.e., your processing logic, that which defines and makes your business work, is in that middle layer. And what we do, the process of modernizing, is to start moving code that heritage or legacy-wise exists in the processing section of your application, because in fact your application only has a processing section. And we want to move code up so that some of the code goes into the interface modules, where the actual handling of the interaction between the user and the system is done. And then another large piece of code follows the route of being taken out of your processing logic and placed into the database where it actually belongs. Now, there's a classic example there, which I will give you now and we'll come back to later. If I want a user on an interface to type in a customer number or type in an order with a valid customer number, is what I meant to say, then the checking to see whether that customer number is valid at the moment is done by your processing logic. It should not be. It should be done by the database, because the database is ultimately responsible for the integrity and the validity of the data. And we will go into that particular statement in a later on. Okay, I've been stamped in the ribs again. When I suggested that it is becoming necessary when you modernize to identify a database engineer or database architect, I left out the fact that this doesn't necessarily have to be a separate person. It might be fairly intensive work to begin with, to start the modernization process. But once it's on its way, that becomes not necessarily a full-time job. And so it doesn't have to be a whole person. It could be a separate function of somebody who is already involved. Okay. Let's have a look at my block diagram of what a modern application should look like. This is what we are trying to achieve. And this particular course is going to cover all the pieces that I have here and how to achieve this. Obviously, it will have to be done in line with your existing application and your requirements of the system, naturally. But everything begins with the physical database. I'll probably come back to this a couple of times as well. The physical database is those physical files in the old DDS paradigm. So, yeah, DDS paradigm. I always get confused with this. And tables that they prefer to call them in the new DDL or SQL paradigm. Both of those form the physical database. And in the physical database is the data that keeps your business from failing. It's as simple as that. Without the database, your business, whatever it is dead. Because every decision that your business management and everybody else in the business makes is based on data that is stored in the physical database. It is the place which is most susceptible to espionage, to hacking. It's a weak spot if you let it be. And if people who shouldn't have get hold of that data, it can damage the business severely. I cannot stress enough that the data in your physical database needs to be protected at all costs. And here's a statistic that you probably don't know, is that accidental or deletion of data or other corruption of data or any other type of data mismanagement or damage is 80% of the time is not deliberate. It's accidental, and it's done by people that work for you. And yet it can still put your business out of operation. So you're not even looking to protect yourself from those industrial espionage spies. You're looking to protect yourself against your own people. And that's not in any way a criticism of anybody. You need to, because that's where most of the problems on a physical database come from. Right. Let's see, what do we do when we're trying to create a modern situation? The first thing we do is we convert as much of our DDS database to DDL as is possible and practical. And the big and most important thing here is we want to do that without altering the level ID of the physical file at all. That is so important, because you do not want to introduce other elements of other problems by being forced into a recompilation of your programs, which can run into the thousands. And if one doesn't compile, you're beginning to introduce errors. So what you need to do is you need to migrate your DDS to DDL without changing the level ID. That means you can simply switch to the DDL, what do they call it, paradigm, engine, whatever it is, the SQL or DDL engine, and you don't have to touch any of your existing code. It carries on running, and nobody even knows that this transition has happened. You can't convert all your DDS files to DDL, because some won't convert. And some of them you may not even want to convert, because they will be just too much trouble to bother with. I'm talking about that 15-year transaction history file that's sitting somewhere and is only used once every 18 months for looking up an ancient transaction because somebody's got a problem with it. Those files are not used. They're not really needed to be converted. The big advantage of moving to the DDL paradigm is the page sizes that you begin to deal with. A DDL file works in 64K page sizes, whereas a DDS file works in 8K page sizes. So almost immediately you should see an improvement in performance, because the physical reads begin to reduce and the logical reads begin to increase. So there's a good reason for doing it, apart from the fact that DDL is the new thing. And in fact, IBM is putting a lot of effort into the DDL. And they are not developing the old index sequential access method type of DDS type of physical file too much anymore, although they have done some significant changes just on the last release. But they are putting most of their effort into the SQL engine, and as a result, it's not a silly idea to follow that and build your database as a DDL. Right. Having said that, that's where the beginning of your attention needs to focus. Now I'm going through these boxes a little bit quicker. Above your physical database, remember the physical database contains your data. The logical database is different ways of looking at that data. This is beginning the process of turning the data into information by giving you different sequences, different combinations, and different content. Logical database. But it is not part of your physical database. Then we have something, and this is what is significant from a modernization perspective, and the start of giving your database its own integrity, making your database self-aware, is the triggered programs, the database triggered programs, which you can attach to physical database files. And these triggered programs, which I'm going to go into in a lot of detail, provide the file itself with the ability to make decisions about the data that it will and will not accept. And these triggered programs are built from code that you take out of your business logic, i.e., you're reducing your business logic by taking away things like data validations. Must this field be a yes or no? Must this field be equal to naught or not equal to naught? All of those validations go into trigger programs and come out of your application code. And that means your physical database is becoming intelligent and it's becoming self-aware. Right. All of these I will be repeating ad infinitum as we carry on. Then we get a thing called I/O services. Translated is input-output services. My other name for it is border control, because it's actually the layer that controls the access of the application to the database, i.e., you are separating your application from your database, and you're providing a border control service which allows the application to access the database under supervision. What was it called? I heard it called recently, delinking the database from the application is one of the main paradigms of modernization. And if you want to give your database autonomy, integrity, and flexibility, decoupling, sorry, there's another word for decoupling your database from your application, then your I/O services are the layer in which this is done. I will cover a number of other reasons why these I/O services are so critical, and I will show you how the I/O service layer goes a long way to help you protect your physical data in your physical database without making a huge effort at all. It's the border control, it's passport control, it's import-export control, and that is all done at that level. And the database, it protects the database from unauthorized access. Then we have another set of services, another service layer. And you will notice that the arrow on the right-hand side here, halfway through the enterprise services to the bottom of the trigger programs, is the model. That is the database. Enterprise services can be translated as being common services that are to be made available to the applications. The one that comes to mind, and the one I use as an example, is VAT calculation or tax calculation. I know that in the United States there are 3 levels of tax. In other countries they may be different, but the rules about how you calculate tax are very standard. And therefore, tax calculations are an enterprise service. They might use multiple logical and physical database files. You can see that from here. Here, this one and this one. Enterprise services can use logical and physical database files directly, as well as through I/O services, because these also have the same protection as your I/O services do. They will not allow uncontrolled access to the database. So that makes up your model. What's below this arrow here are more or less services that are focused on the database and usually on multiple database files, whereas the I/O services tend to be a one-for-one relationship with a physical database. The enterprise can combine more than one physical file or logical file into a service. The piece above, of course, is part of your application code, which forms the controller. So your application code makes use of enterprise services and I/O services, and therefore, as you can see, has no direct access to the physical database and or the logical database. And thus, you've managed to achieve a decoupling of the database from the application. Sorry, my mouse drawing is not great. So you've decoupled your application code from the database. What's below this line here, under the model, belongs in the database. The I/O server controls who can and who can't have access to this. The triggers determine whether the data is valid or not, and so on. So this is the big part of modernizing, is modernizing your database. I'm going to put in the user interface, which comes above that. Pointer options error. The user interface forms the view, which interacts with the application code and through the application code with the database, but has no direct access to the database. Now, there's one other thing that I add here, and I put this in reluctantly, because in fact, using embedded DML in your application code for quick access to your logical and your physical database is acceptable under certain circumstances. But I must stress that look at the way these arrows go. It's acceptable if you do this to extract data from either your logical or your physical database. But done properly, you will not be able to put data into your physical database directly from your application code. Whereas you'll see all the other arrows in this whole picture have a multi-directional, a two-directional function. This one is one direction only. Break that rule and you're exposing your database to all sorts of problems. Okay. So this is the stack that we're looking at for a modern application. And we will mostly be dealing with the database and application code changes, not to rewrite your applications, because only you can do that. But we will look at application code and the way of moving code from application to triggers and to consolidate application code into enterprise services so that you can reduce the amount of actual business logic in your application layer. And my experience and practical examples of this have shown me, and you will not believe me, nobody ever does, but you can reduce the number of lines of RPG code that you currently have in your application by up to 80%. Because 80% of the code that you currently have in your application programs is either user interface or database, and should be placed where it does the most good. Now, over time, and if you follow the modernization roadmap, you will get there and you will say, okay, 80% is not beyond doubt.
זה היתרונות.
So now I've lost my train of thought there for a moment. Okay, let's just leave it at that. This is where we're going, and we're going to talk a lot about it. And examine how one can achieve this. And of course, each one of you individually will then need to examine your own systems and look at the best method to apply these things to your systems. However, there's one thing that we've left out of this database modernization discussion so far, is the metadata that makes up your physical database. Now, one element of that metadata are fields in files in your database. And a definition of a field is a definition of a space in your database that contains data. So it's a data field. And that element of data that is stored in a data field is defined or is characterized by the definition of that field, i.e., it has a name, which can either be the old 10-character RPG data name, or it can be the new 3,726-character SQL long name. But it's got a name, it's got an attribute, a type. It's either a character, or it's a numeric, or it's whatever else. It has a length, and it has a text description. It has a default value, and it has various other components that define that data element. Now, the problem that we've encountered with many legacy systems is that each data item in your business has multiple definitions. These occur over time, and it's actually extremely difficult to avoid them. Even AO, even at Zero Optima, which is a product that has been built using modernization philosophy from the ground up, even this product has duplicate data elements, so it's not easy to do. But if you want to give your database meaning, and particularly if you want to use it for data analytics, and there are a bunch of other things that are becoming very important to people. Data analytics is one of them. You need to have a single name and definition for each different data element. And you don't need to have data elements, the same data element described in 16 different ways. And so part of your modernization, the modernization process, works in two loops. And this is what I want to show you here. The first thing is you need to extract the dictionary. We call it a data dictionary. Legacy people will know it as a field reference file. It is a storage space for all your data elements that make up your database. And the AO product provides tools which will help you sanitize that dictionary, i.e., to eliminate the duplicates, group them together, identify what is the correct definition for that data element. And you can do this as a little trick if you want to. You can write down on a piece of paper how many different data elements you think your database contains. Write it down and put it in an envelope and stick it closed and give it to somebody. Then go to our website and download a thing called AO Inspector. It's free. You just install it and you can run it against your database schemas, your database libraries. And it will tell you actually how many distinct data elements exist in your database. And you will actually be quite horrified. It will be at least 4 to 5 times more than you wrote down on that piece of paper, if not more. So one of the processes of trying to get a modern database is to sanitize the dictionary and to clean up the metadata, enrich the metadata, standardize descriptions and defaults and everything else, and then feed that back into your database eventually. The other loop is to build your validation into DB2, i.e. taking the validation out of your program logic, placing it into trigger programs, and validating the data at the database level, not at your application level. Then to add relationships into the DB2 database, which will further validate relationships between two files. And then that takes you back into the database modernization. And you go around those two loops. And the idea around this approach is that you reduce the risk to almost zero. And if you use a test environment in which to do this exercise, you create zero risk to your production system. You can do this in small bites, one file at a time. Sorry, I just need to... Oh, okay. So these are the two loops that actually make up your database modernization. And as I say, you can iterate in big chunks or small chunks. And obviously, as in our experience, with people who've actually been working with us on this thing, that the preference is to start with very small bites, one file at a time, and preferably in one case, not even a production system, but an extract from a production system. So it's part of the production database. And then to begin working one file at a time until you begin to understand the concept of where you're going with this thing. You gain the skills, you gain the confidence. And then you can take bigger and bigger and bigger chunks to accelerate the modernization process. But the important thing here is you are, as I've said before, and I will say it again, and I will probably say it many times more, you have to go through a learning curve. It's not an easy exercise. It's not difficult if you follow some basic rules of modernization and use the tools that are provided by IBMI. It can be done, and it can be done with confidence. Let me just explain where the AO product fits in here. Atzera Optima was a product that has been developed over a large number of years, which actually controls, documents, and manages a DB2 relational database. It provides tools to extract data dictionaries, to sanitize data dictionaries, to add triggers, to manage the entire database and its logical relationships in one interface in one place. It allows you to create new files, to change existing files, and then to promote them through a development, test, and production environment. So it is basically a database development and management tool. It also has internal data dictionary. So you don't use a field reference file because, in fact, SQL or DDL doesn't use field reference files and doesn't have that type of functionality. So Atzera Optima can actually provide that functionality. Okay, so that's where we've talked a lot about modernization. And now I think if I click this button, we get the question mark. So now we get to a point where you can, if you have any questions, ask them of me. Otherwise, I will carry on. That's about the best thing I can say. Right, obviously, this is one of Albert Einstein's sayings, and it highlights the importance of what I'm trying to do here. Right, I have got a question from a couple of people. Let's just deal with those first. Let's put the question mark back. Right, if a field in the database should have a value of Y or N, the validation of the data entry in a display file should be a trigger program rather than the value statement of a data entry field. Right. The answer to this is all validation must be done at the trigger level. And this is a key because, remember, in 1979, when I was writing RPG2, we had to create the display file before anybody could interact with the application, and via the application could interact with the database. We only had one way of interacting with the database in those days. When these systems began to evolve, we had only the application interface that was provided, which we could use to interact with the database. Think about, at this point in time, how many SQL clients there are available, free of charge, for download to any PC that can interact via JDBC, ODBC with an IBM I database. So, the purpose of validation is it's done at the data file, so that you cannot manipulate data in that file by bypassing the normal application. What the view, the function of the view changes slightly. The view, which is the actual interface that the user is communicating with the system, that now has a slightly different role. Its job is to collect information from the data from the user, or information from the user, transfer it to the database with or without some intermediate processing, look at what the database thinks of the data, i.e., did the database accept it or not. If the database accepted that data, the interface then tells the user that that data has been accepted. But if the database did not accept that data, then the interface's job at that point is to collect the reason for the rejection, pass it on to the client, the user, and ask him what he wants to do about it. And of course, the user has one of two choices. He either cancels the transaction or he fixes it. Because just by pressing the enter again and sending the same data back to the database a second time is not going to change the database's mind. And the database will then say, I don't want this data, sort it out. So the answer to your question, Ed, is yes. You are absolutely correct. We don't want to validate the data on the face of the screen. We want to validate it at the database. Having said that, there are some people who believe that they should validate each field typed onto a screen, particularly a graphic screen, at the time that that field is completed, so they can give the user the earliest warning that they've typed in something incorrect. That's a school of thought. Field-based processing instead of record-based processing. A lot of validation of field A will depend on what is typed into field B. Therefore, you can't validate field A before you've typed in field B, and so on and so forth. So, field-based validation, you can put that in as well. But that must not inhibit you from doing that validation at the database level as well. So yes, you might be coding a double validation. It's possible. But that's better than no validation, believe me. And there are ways where we can get the user interface to actually use exactly the same code as the trigger program to do the validation. I'll show you that later on. So that actually the same procedure is used to validate the value of a field. So although you're doing it in two different places, you're not actually duplicating the code. That's the important thing. Because you can't have one program validating yes, no, and another program validating yes, no, and maybe as an alternative, because that's unacceptable. So we will discuss that in a lot more detail later. Okay, a question here is when you convert a DDS to DDL, Does the data transfer when created, or do you have to migrate? The data, when we're talking about migration from DDS to DDL, you're migrating the file, not the data. You might want to test it with a small amount of test data to make sure it's migrating properly. But generally speaking, you will create a totally new library schema containing the new data files, and then you will migrate the data from your existing database to the new database once you're satisfied that all is in order. Difficulty here is some organizations have small amounts of data, others have massive amounts of data. Some organizations are 24/7. You've got to plan to migrate the data. And this is another reason why we advocate no change to level ID. Because it's bad enough having to plan in the migration of massive amounts of data without having to worry about the fact that a program, when you go live on Monday morning, doesn't work because there's a level ID mismatch. That you don't need. So they are two different things. You want to build your DDL database, then once you're happy with it, you put your data in and carry on processing. First step to modernization, another question. First step to modernization, metadata or DDS, DDL migration? Either, both, or neither. Nathan, I'm sorry to answer that question like that, but that's what it is. Typically, you can work with all of it at the same time. You can even start with triggers. There are many places to begin the database migration, database modernization. There are a massive number of places to begin. And in fact, in a lot of cases, you tend to follow different threads of modernization simultaneously. Like you might have one team adding triggers to certain physical files and logging the problems. We'll discuss that later. And you might have another team that does the dictionary sanitization, cleans up the metadata, and starts creating a proper consolidated data dictionary. So it's definitely a yes, no, maybe. It's where, once you understand what is involved in going from now to the future, to modernize, then you've got to decide where to start. And this, I will be making recommendations as we go along as to the best ways to start. But unfortunately, a lot of that requires knowledge of your systems in order to actually make that work. So very often I can make a statement and I'm going to have to then take it further with a particular customer because they have a particular database and a particular application, and therefore the application of a suggested solution is different for them than it is for other people. So that's the difficulty in that environment. Okay. Thank you, guys. That was fun. Right. Can I proceed, or are there more? Okay. Let's carry on. I was coming back to this thing here, and I actually touched on it in my last sentence. Education is not the learning of facts. That's, in this particular case, this is more true than in a lot of other cases. Modernization, there's no facts that you can learn by rote. There's no silver bullet. You need to get your mind modernized to think in the right paradigm. You can see I'm repeating myself somewhat. Oh dear. Sorry, I've lost my clock, which I can't have because I've got to know. Okay, I've got to know what the time is. Right, let's see. Does this come up with a question mark? No, this is just, the ones that don't come up with question marks are just breaks. All right. I'm going to, we've probably got just about enough time to cover this next topic. IBM Rational Developer for Power Systems. Now, I'm fanatic about RPG. I'm fanatic about the database. And I'm completely and utterly fanatical about RDI. This is probably the best thing that IBM has ever done for application developers since they invented DB2. It's a client tool that gives you an interactive development environment that is so powerful. Let me click on this because I think I'm repeating myself. Highly functional, flexible management and code development interface. For, but not limited to, the IBM I. So, in fact, this is a client. It runs on your PC or your desktop or whatever it is. And you can use it for other languages. You notice I hesitated to say anything about that. But it does have plugins for all the various different languages, PHP, C, Sharp, and all the rest of it. But of course, I'm not interested in those. I'm interested in RPG and the IBM I. And it is the most powerful tool. Now, I will be using it continuously throughout this course. I will be using it to show you code, to manipulate code, to work with code, and so on and so forth. So, the problem is that I use it the way I'm comfortable with using it. The result of this capability and RDI's ability to allow the user to personalize and customize the interface to suit individual preferences, it is not possible to provide a step-by-step how-to for the product. You don't get a dummy's guide to RDI. RDI has got a lot of help, and it's a matter of clicking buttons. I will use it as we move forward into the coding sections, and you will see some of its capability. If you want to stop me and say, if you're using RDI and you want to stop me because I've done something and you would like some explanation, you're more than welcome. It's an extremely powerful tool, and I love it because my productivity has gone up since I started using its baby brother, WDSC. I started using that in 2003. And I don't use SEU at all anymore, or PDM for that matter, because RDI gives me all the capability I want and then some. So it's a PDM, SEU, RDP function on steroids times 10. And I will simply show you as we go along the various different ways. The walkabout session will introduce you to multiple capabilities of RDP and provide guidelines for the use and customization of the feature and functions. Whoops, where have I've got, okay. RDI will be used exclusively through the following sessions of this course and will therefore provide many opportunities to consolidate understanding and skill with the product. So I'm going to, I'd like to just take a vote here. If you currently use RDI, can you just unmute your mic? Okay. All right, thank you. I can mute up again. We've got about half the people on board who are using RDI, And the rest should seriously considering approaching management. It is a paid license, unfortunately, but in the development shop, it will pay for itself in terms of productivity within 6 months, is my opinion. Again, there's a learning curve involved and there's a customization. So what I'm going to do now is to do a little bit of a walkabout. I am currently using 851. This was an old slide. And the plugin that I use is RPG and COBOL Development Tools for I. I use 851. I know there's a 9. Okay. If there are people who don't have AS400s, we can make a plan. Believe me. I know there's 9.2. I think, Kay, you're using 9.2 something. Is it 9.2.1? I just have not moved off 8.5. I'm so comfortable with it. And yes, I know there's probably a few features, but you know, old dog, new tricks and all of that sort of thing. 9.5, 9.5, goodness, they really are winding this thing up. So in fact, they are developing this rational RDI quite significantly. I'm going to switch over to RDI now. I've just got to try and okay, let me just switch this off. And I want to open up RDI. For those of you that are using RDI, this might be a little bit okay. Okay, as you can see, Marinus has sent me a message which says, if they so wish, they can request some resources from me, providing the motivation and ROI figures for management. So we can help you if you want to justify. We can provide you with some resources to investigate it and the ROI for justification to help you. The license, I think it's either 60 or 90 days. I think it's 90 days. You can actually download it from DeveloperWorks, and you have a 90-day free use of it as a license. So we can provide you some resources to test it, to play with it, and to develop an ROI for development. What you're seeing here was the last session. I'm working on the Zero Optima product. I'm enhancing the interface around authorities. And I have all these source members are open in my RDI. This screen is a 22-inch screen. Oh, there are 4 more there. So those are all the source files I have open simultaneously. And on this side, I've got 1, 2, 3, 4, 5 source files open as well. So all in all, I have a bunch of source files open. I can cut and paste from both sides. I can drag and drop. There are many tools. What I'm going to do is I'm going to simply go back to the beginning, and I'm going to close all of these, and I'm going to close all of those. I had one guy who was working for me, called me to offer him some advice, and I went down to his desk, and he had 127 source files open in RDI. I would like to actually have a 105-inch screen for RDI, because the amount of real estate you need is quite, the more real estate you have on your screens, the more flexibility you have with RDI. So it really is a powerful tool. This is my customized version of RDI. So what I'm going to do is I'm going to start by going to File, and I'm going to click Switch Workspace, Other. Now, RDI is based on a workspace. When you boot RDI, you boot up using a default workspace, which you can set. You can set the default workspace, and you can see that mine is TEMBO Workspace AO. That's my workspace that I use, and that's the only one I use. All your personal and private configurations are stored in this workspace. And therefore, those of you that are using it, and those of you that intend to use it in the future, will you please make sure of two things. First of all, create your own workspace, which is based on the root directory, not your Windows user resources, zing, 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 zing. Keep it as short as possible and create a workspace for yourself. As you can see, I've kept mine fairly short. And the second thing is, back it up daily. Unless you have a LAN server, and you can create your workspace on that LAN server, which gets backed up at regular intervals. Back it up daily, because everything you do with RDI causes changes in your workspace. And there's nothing more infuriating than spending a couple of hours setting up a whole bunch of filters and giving yourself a configuration that you want to work with for this particular project, and only to find that something's gone wrong, you reinstall your workspace, and you've lost all that setup. So you need to back up this. Now I know, I say it, I can say it, and I can see the grins on every single one of your faces, particularly those who act as consultants. Do as I say, not as I do, is a good one. And in this case, you back it up on a daily basis. The other thing is, as I say, keep it out of your general area that can be overwritten by a reload or anything that Windows happens to do. You want to keep it out of that. So this is my workspace. If I want to change a workspace, let me see if I've got a workspace I can change to. No, I only use the one workspace. But I can swap to other workspaces, and so you can have different workspaces, but RDI will always load to the last workspace it was on when you closed it down. So workspace is the underlying definition of RDI. And just to show you this one, so you realize that my next statement is not going to be out of place. If you look at this workspace, you will see that it is quite large. and it has nested directories after nested directories. Some of it takes you down to source code. Others, you've got metadata, which has got plugins, and these are all the RDI plugins that you are using as part of your workspace. And if I just right-click on this and do properties, you will see that, in fact, my workspace is very big. Actually, it's bigger than I thought it was. 674 meg. It contains 49, nearly 50,000 files. So, two things about this. If you ever want to restore your workspace, always restore it to exactly the same path as you took it from. Because if you change the path, things will go haywire. So AO, C TEMBO workspaces AO is the path. If I ever intend to restore this onto another computer, for example, I must restore it into the same path that I took it from. And being 674 odd meg, it actually does take a while to back up. But it is essential that you back it up at very regular intervals. In fact, I'm going to back mine up immediately I'm finished here because I didn't realize how long ago I'd backed it up. Okay, so that is the workspace. It is based on the workspace. Now, the next, I'm going to just change this. Dock on top right. When you first open RDI, you will see a couple of things across the top here. These are called perspectives. A perspective is a group of tabs. I will open my this perspective that we're actually looking at now is my remote edit perspective, i.e., I have a view of source files. I've built these up myself. We will talk about that probably next week quickly in the beginning. And I have this big gray window is my editing window. So I can select from here a source file, and then I can double click it, and it will open up the source in the editing window. And I can do that over and over again. I can have many sources in the window. That is a remote edit perspective. This here is the perspective I use for debugging. There's a debug controller this side. Again, that we can go into in a little bit more detail when I actually do debug something later on in the workshop. There's the remote systems perspective, which is this one, where these are Java errors. This is an objects table. This is a tab. I've highlighted it. It's got a color, and that is a tab, and it's an objects table, and it's very much like the PDM objects table, except it has a lot more power. You can lock it. You can subset it. You can work with previous versions of it. You can control how many columns you've got. You can export it to a file, and so on and so forth. So it has a lot of functionality. So we have perspectives, and inside a perspective you have a number of tabs. Some tabs, if I drag this over, I can now, in this particular perspective, I can see my edit window, and I can see my object table. In the remote edit, my remote system list is this side. The object table is not one of the tabs. And of course, the debug has the source window as well, because this is where you debug and step. These are the various debug controls up here. So perspectives allow you to gather certain types of tabs that suit your way of working. And this is where it becomes very difficult. I don't like my perspectives on the top there. I like my perspectives on the left-hand side, this little left-hand side window here, the bar, left-hand bar. I like them there, and because I know what the pictures mean, I don't need the text. So I right-click on it, and I say, take away the text, don't show the text. Then I say, dock on left-hand side, and it docks it on the left-hand side for me. I'm going to move this one down to there. I'll show you that. So I've got my 4 little perspectives docked here. And that's how I like them, because I know what they are. There you can see the little bug is the debug, and so on. They're readable. Once you get used to it, it's one of these things that takes a little while. Tabs, you can have as many different tabs as you like. Now, here is something about RDI that you've got to understand. Everywhere on any screen, at any place in RDI, you can right-click, and you will get context-sensitive menus. Anywhere. If I go into this mode, I can click on this table and I get a context-sensitive menu for that line that is clicked on. So, to learn to use RDI properly, you have to know where your right-click button is. Now, it's the right-hand side of the mouse, and you use it a lot when you first go into RDI. You can point at anything and right-click it. These little white arrows are also menus that relate to the tab that you're busy working with. So the white arrow is context for the tab, whereas on an entry, it's context for the entry. You hover, and you've got little hints that tell you what they are. Lock this view, move up one level. So what you have to learn to do, there's a minimize, there's a maximize. If you minimize it, it gets parked off to the right-hand bar. So you've got a right-hand bar, you've got a left-hand bar, you've got a lot of things parked off here. All of these tabs are tabs that have been parked. There's the commands log, there's a search panel, and there's, what's this? That's the remote object table. So you can drag a tab from one box into another box. You can pull a tab down to be the bottom of that half. You can take this tab and you can pull it right down to the bottom so it goes below that, or you can pull it up. All I'm doing here is I'm showing you that the tabs, or the things, can be moved around and placed wherever you want them to be. Of course, I'm going to regret doing this because I'm going to have to put this all right again when I want to start work tomorrow morning. But tabs, right-click, they've got a context menu. If you wish to, for example, this object table, I can right-click and I can create a detached view of that. Now I've got an object table, apologize, detached view. There's the object table. It's now detached. Now I have two screens. I'm showing you just one of them, but I have two screens here. I can move this off to the side and put it on the other screen. And I can bring it back. If I don't want it to be detached, I can make it a fast view, which means it gets parked down the bottom here. And I can open it and then close it. So I've got different ways to define the tabs within a perspective, and the whole lot is clumped together in the workspace. So you can see I move things around all the time. When it's convenient for me, I want to have this over here because that's what I'm working with. And I want to switch to another perspective because this is what I'm doing here, and I'll switch back to that perspective, and so on and so forth. So I want this to be here on this side, and I want to close that window up. And this command log, I want to be I want to minimize, and it goes to this side here. Pull that down. So I'm moving things around all the time. And the construction of what I'm moving around is all stored inside the workspace. I'm trying to do this to highlight the fact that you need to save this workspace. Otherwise, when you come back, the workspace will load, and if nothing has gone wrong, you will see exactly where you were when you left off. But if you've had to restore your workspace, you're going to lose stuff, or you're going to have stuff looking very different to what you wanted it to be at one point in time. All right. There are other things I would like to quickly go through with this Ops Navigator, but I can't, as I said, show you. Okay. Marinus has asked me to explain my color scheme. When I was lecturing, I was telling people how RDI is the best thing since sliced bread, and I don't use SEU, and really PDM is a no-no. And as soon as I brought this particular panel up, everybody in the whole room said to me, "But you're using a green screen." I said, it's not a green screen. It's an RDI screen that I have chosen to put green on black because I find that the most restful color for editing source code. You can choose the color scheme that you build for your editing, your source panel, your source editor, and that I will go through on Thursday. I will start with this and just run through some other parameters and where you can find them. Is there any particular feelings as to whether I should continue along this line or just show them up as I go along? There's quite a lot of things, bits and pieces to show how powerful it is, and I just want to be sure that I've got you people interested enough to listen to me extol its virtues for a little bit longer. It won't be much longer. But we've got to 7 o'clock, and I have done what I have done with the rational developer. But there is still more that I would like to show you before we move on to the next topic. Okay. So everybody's happy if I just pick up from here and carry on Thursday? I'm assuming, unless somebody, if you want to disagree with me, just unmute your mic. Then I will know that you have an objection. Otherwise, thank you very much for your attention. I know it's been shocking and it's been high speed. It will become clearer later. Of that, I promise you. So let it sink in and we'll see you on Thursday. Thanks very much for your attendance.